This is a revision video for pressure in a fluid, and this is for triple students only. And when they say fluid, we mean gases or liquids, anything that can flow. So not just gases, not just liquids, either or. Pressure is always at 90 degrees. Could be a gas molecule, gas particle colliding with a container ball, that will be at 90 degrees. It could be a water pressure colliding with a scuba diver's flipper, but that'll be at 90 degrees. Pressure is always at 90 degrees. To calculate pressure, it's the force divided by the area, which you may have learnt at Key Stage 3 as measured in newtons per metre squared. But AQA GCSE physics, pressure is measured in Pascal, so newton per metre squared is exactly the same as Pascal, which is what pressure is measured in. Converting centimetres squared to metres squared to use in this equation is a little bit more complicated than just dividing it by 100 like you would for a distance of 50 centimetres. So if we've got 50 centimetres squared, we don't just divide it by 100, we have to divide it by 100 twice. So 50 divided by 100 divided by 100 equals 5 times 10 to the minus 3 equals 5 times 10 to the minus 3 metres squared. And the reason why this is because centimetres squared is centimetres times centimetres. So we need to do divide by 100 divided by 100 to convert it to metres by metres. We can calculate pressure in liquids using this equation. Pressure in pascals equals height of the column, which will make more sense in a minute, in metres, times by density of the liquid in kilograms per metres cubed, times by the gravitational field strength in newtons per kilos. And this height of the column, I've drawn two pictures to elaborate on this. In the first one, X is halfway down this beaker of water. It's halfway submerged. Because it's got this amount of water above it, those water particles have got mass, it's got a small amount of mass. Because it's got a small amount of mass above it, it's got a smaller pressure than this example, which we'll talk about in a minute. And this pressure down is equal to the force upwards. This force upwards is equal to the upthrust. This force upwards we call the upthrust. In this second example here, I've got a greater column of water above. Greater column of water above, so I've got more mass, got more particles of water, so there's a greater pressure acting at point X. Because there's a greater pressure acting at point X, there's a greater upthrust. So force upwards is called upthrust, and that's due to the pressure. So the further down you go in a liquid, the more upthrust you get because there's more pressure. Why do objects float? So for example, if the upthrust is equal to the weight, it will float. Or if the upthrust is greater than or equal to the weight, it will not only just float, it will then actually start floating off into the air as well when it gets to the surface. So to get the upthrust to equal the weight, you can have a large surface area. So if you go back to the equation up there, large surface area decreases the pressure. We can also make it less dense than the liquid. If we get it less dense than the liquid, it's more likely to float. Well, it will float. For example, oil on water, less dense. Oil is less dense than water, so it floats. To cause something to sink, the weight, the force downwards, needs to be greater than the upthrust. The weight downward needs to be greater than the upthrust, so we have more mass or smaller surface area, so we get a greater pressure. And we also want to be more dense than liquid. For example, if we use a lead cube, lead is denser than water, so lead will sink.